The demand of commodities, fine chemicals, aroma compounds, proteins, or medicines such as antibiotics is increasing worldwide. However, conventional biotechnology production processes based on monocultures of microbial flora are reaching their limits. So how can new, more efficient production routes be created by scale-up that not only meet demand, but are also economically viable and sustainable? Roughly speaking, this is what the DFG Priority Program InterZell is about. We will be exploring this topic piece by piece with our podcast, Lab Whispers about bioengineering. Sustainable production is becoming increasingly important. For example, second-generation biofuels could be produced by the use of microorganisms. The PEB Cascade project, one of 10 projects funded by the German Research Foundation DFG as part of the InterZell network, aims to establish a self-sufficient reaction cascade for the production of biofuel. In order to realize this novel production cascade, molecular biological know-how is combined with biochemical process engineering. We are discussing this today with Professor Roland Ulber, RPTU Kaiserslautern, and Professor Dirk Holtmann, KIT in Karlsruhe. I'm looking forward to hearing what can be done with biotechnologically produced ethyl butyrate and how it can be used in engines for mobility. Welcome again, and thank you very much for being here. Would you like to briefly introduce yourselves?
My name is Dirk Holtmann, and I studied chemical engineering and biotechnology, and I'm now professor for electrobiotechnology at the Karlsruhe Institute of Technology. Besides electrobiotechnology, in my group, we investigate the use of waste materials and renewables, enzyme technology, C1 biotechnology, and all of these research can be put together under the umbrella of intensification of bioprocesses.
Also from my side, my name is Roland Ulber. I studied chemistry, but 20 years ago I switched to the engineering part of the University of Kaiserslautern, now named as Rheinland-Pfälzische Technische Universität Kaiserslautern-Landau. It's a very long name. So we are working in nearly the same area as Dirk do. We have great project potentials in renewable resources, also a little bit in electrobiotechnology and in phototrophic biosystems.
And how did you become involved in the overall DFG InterZell program?
First of all, Roland was one of the initiators of the priority program, and both of us worked with a lot of the colleagues involved in the program together, and therefore it was a great possibility to work with the colleagues together now, and we are very happy to be part of this InterZell family.
What fascinates you the most about the InterZell priority program?
What fascinates me the most about the SPP InterZell is its innovative approach to understanding and manipulating cellular interaction within complex biological systems. This program is at the forefront of merging cutting-edge technology and interdisciplinary research to explore cellular communications and cooperation in unprecedented ways. InterZell brings together experts from various fields such as biotechnology, bioprocess engineering, and microbiology and computer science. This collaboration fosters a comprehensive understanding of microbiological systems, enabling the development of more executive processes. InterZell also plays a critical role in training the next generation of scientists.
And what is the goal of your research project? And please tell me about a highlight so far.
Our project PEP Cascade aims to investigate a self-sufficient biotechnology reaction cascade for the production of the fuel and aroma component ethyl butyrate. In general, ester production is a complex process involving several steps, such as the production of the precursors, here an alcohol and a carboxylic acid, and a chemical or enzymatic esterification, and finally the product separation. Our approach is to use artificial anaerobic mixed culture of a Clostridia and a yeast or a bacteria. It will be investigated in combination with a surface-expressed lipase to produce the ester in one reaction system. While the Clostridia are responsible for the production of the butyrate, the yeast or the bacteria will produce the ethanol, and the lipase is responsible for the esterification. This approach is expected to result in an optimized productivity, as each organism is used to produce one component and can thus be brought to an optimal process state. And you also ask about the highlight.
Yes.
I think the most important highlight so far is it works. We are just in the beginning of our project. We started for 1 year ago, and at the moment we are able to produce around 10 grams per liter of the ethyl butyrate already. And we both believe that it will be improved during the project. And therefore, this is, in my opinion, the most important highlight at the moment.
Yeah, sounds great. So, my understanding is that different microbial strains will be investigated to determine appropriate surface expression of lipase as one of the important enzymes. Why is this important?
In general, the use of a surface displayed enzyme could combine the most advantages of whole cell biocatalysis and the catalysis with isolated enzymes. In general, the display of enzymes on the cell surface of the microsome may be advantageous for simplified process design. Surface display of enzymes also has the advantage of over-established immobilization methods. Enzyme immobilization on solid matrices is often challenging due to the sensitivity of the protein conformation, the desired purity of the enzymes, and the requirements for particular support properties and immobilization techniques. These challenges can be circumvented by the use of surface displayed enzymes. Surface display enzymes is mainly used in screening approach, but can also be used in production processes as in our project.
And you are planning to test biotechnologically produced ethyl butyrate in a single cylinder gasoline engine. Do you believe that biotechnologically produced ethyl butyrate can serve as an energy source for the mobility in the future?
Absolutely. I believe that biotechnology produced ethyl butyrate holds great potential as a future energy source for mobility. There are several compelling reasons for this optimism. Ethyl butyrate produced biotechnology is derived from renewable resources, which make it a more sustainable alternative to fossil fuels. Using biological processes to produce this compound can significantly reduce our carbon footprint and reliance on non-renewable energy sources. Ethyl butyrate has properties that make it compatible with current internal combustion engines, like the single-cell gasoline engine we are planning to test. This means it could be used as a drop-in fuel or blended with traditional gasoline, facilitating a smoother transition to greener fuels without requiring significant modification to existing infrastructures.
And there are always obstacles and challenges. So, where do you see the biggest ones and how do you want to meet them?
In general, I see three main challenges. The first one, as already mentioned, we would like to combine three biological activities: the ethanol production, the butyrate production, and the esterification in one reactor, one reaction system. This would solve many technical problems, but it also presents us with the challenge of finding an optimal conditions or compromise between the different tasks for the different biological activities. We want to tackle them by experiments and additional model-based optimization. The second challenge is the scalability. While we are working on a laboratory scale, we need to think about transferring this to an industrial scale. We want to achieve this by scaling up into 30-liter scale during the course of the project and gain important insights for the subsequent transfer in industrial scale. And the third challenge is the final price of the produced ethyl butyrate. We optimize yields and productivity during the project to produce a commercial product. However, there are also a lot of political influences on the price of fossil or bio-based fuels, which can only be influenced to a limited extent by us as researchers.
Please tell me about the milestones you are working towards, and will it be possible to transfer the research to an industrial scale?
We think yes, we are working towards several exciting new milestones that will help advance our research and facilitate the transfer to an industrial scale. One of our primary goals is to optimize the biotechnological production process for our product. This involves refining the microbial strains and fermentation techniques to increase yield, reduce the costs, and enhance the overall efficiency of production. Achieving these improvements is critical for making industrial-scale production viable. We are conducting comprehensive tests of ethyl butyrate in single-cell gasoline engines to evaluate its performance, combustion characteristics, and emission profiles. These tests will provide critical data on how well the fuel performs under various operation conditions and will help us fine-tune the formulation for optimal engine compatibility and efficiency. With continued innovation and collaboration, we are optimistic about the future of the sustainable energy source.
Sustainable production is becoming increasingly important. With the second generation biofuel, which is produced with the help of microorganisms, the researchers want to establish a self-sufficient reaction cascade for the production of biofuel. Thank you so much, Professor Roland Ulber and Professor Dirk Holtmann, for your amazing insights into your research.
Thank you.
Thank you.
This is the last episode about our 10 research projects in the InterZell Priority Program. These projects have all been funded by the German Research Foundation, DFG.